Hey there and welcome. Today we are going on a really cool journey. We're going to follow a single click from the very tip of your finger deep into the microscopic world of your computer and then all the way out into the huge connected world of the web. So let's get started. It seems almost like magic, right? You tap a key and boom, a letter just appears. You click a mouse, a video starts to play. But behind that instant gratification is an unbelievably fast chain of events, a whole cascade of logic that happens in billionths of a second. So what is actually going on in that split second? That's the big question we're diving into today. So our journey begins right at that boundary between our world and the digital one. It's all about how we take an idea or an action from our head and translate it into a language that the machine can actually understand. We do that translation using what we call input devices. Whether it's a keyboard turning your press into a tiny electrical signal or a microphone turning the sound of your voice into a digital stream. These are basically the senses of the computer. Each one is a little translator, and they all kick off this fundamental four-step cycle that every computer uses. Honestly, every single computer, from the massive supercomputers to the tiny one in your watch, runs on this really elegant cycle. First, you give it an input. Then, the central processing unit, the CPU, processes that input. Next, you get an output, something you can see on a screen or hear from a speaker. And finally, if you want, the computer can store that result for later. This simple little loop is the blueprint for pretty much all of modern computing. Okay, so we've sent our command into the machine. Now, let's follow that signal into the computer's core. The digital brain, where it's all about pure, cold logic. In here, everything is split into two big categories, hardware and software. A really easy way to think about it is that the hardware is the body. It's the physical stuff you can actually touch, the screen, the keyboard, the chips. But the software? That's the mind. It's all the code and instructions that tell the body what to do. The hardware gives the software a place to run, but it's the software that makes that hunk of metal and plastic so incredibly powerful. And the conductor of this whole orchestra is the operating system, or OS. The OS is the master program, the big boss that manages all of the computer's resources. It's juggling memory, telling the CPU what to work on next, and handling all the requests from all your other apps. It's the essential middleman that lets a program like your web browser run without needing to know the nitty-gritty details of the hardware it's running on. And all of this really reveals the computer's main job, transformation. It takes in raw data, which is really just a bunch of meaningless ones and zeros that could represent text or pixels, and it processes all of that into useful information. For example, that long string of numbers tied to your bank account, that's data. But the nicely formatted statement on your screen that clearly tells you if you have enough money for a new video game, that's information. It's like digital alchemy, turning raw facts into something that actually means something to us. Now, to process all of that data, the computer needs a place to work. It needs a spot to hold things for a moment for super fast access and another place to save things for good. And this is where the computer's memory comes into play. First up, we've got RAM, which stands for Random Access Memory. The best way to picture it is as the computer's workbench. When you open a program, all its code and data get loaded onto this workbench. It's called random access because the computer's brain, the CPU, can jump to any spot on the workbench instantly, which is what makes everything feel so snappy. But there's a catch. It's a temporary workbench. The second you turn the power off, everything on it gets wiped clean. So that brings us to the difference between the two types of memory. It's really simple. If RAM is the temporary workbench you use for whatever you're doing right now, then storage, like your hard drive, is the permanent filing cabinet. You use the super fast workbench while you're working, but when you're all done, you hit save, and that file gets put away in the filing cabinet for safekeeping. And that filing cabinet comes in a lot of different shapes and sizes. Older computers use those mechanical hard disk drives with the spinning disks inside. But most modern computers use solid-state drives, or SSDs, which are way faster because they have no moving parts. And then, of course, you have the portable options like USB drives, and the biggest filing cabinet of all, cloud storage, which, let's be honest, is just a fancy way of saying you're saving your stuff on someone else's giant computer over the internet. So far, our whole journey has taken place inside one computer, all by itself. But the real magic, the thing that changed everything, happens when we connect that one machine to a global network of billions of others. So let's zoom out and get connected. All right, this is a big one. People use internet and World Wide Web interchangeably all the time, But they are not the same thing. The distinction is actually really important. The internet is the infrastructure. It's the physical highways made of fiber optic cables and routers that connect everything together. The World Wide Web, on the other hand, is just one of the things that uses those highways. Think of the web as all the destinations, the billions of pages you can visit. The internet is the road. The web is the place you're going. So, how does your computer find one specific machine out of billions on this giant network? Well, it uses an IP address, which stands for Internet Protocol Address. Every single device that connects to the internet gets one of these unique numerical labels. It's basically the computer's street address, and it makes sure all the little packets of data get to exactly the right place. But let's be real, can you imagine having to memorize a long string of numbers for every single website you wanted to visit? No way! That's where domain names come in. They're the human-friendly names for those nerdy IP addresses. When you type in a domain name, a massive global phone book called the Domain Name System, or DNS, instantly looks up the right IP address and connects you. It's a lifesaver. When you put it all together, you get a URL, a Uniform Resource Locator. It's a complete set of driving directions for the web. You've got the protocol, like HTTPS, which sets the rules for the conversation. You have the domain name, which is the server you're trying to reach. And then you have the path, which points to the exact page or file you want to see at that destination. We did it. We've followed our click all the way from a key press to a web page delivered from maybe halfway around the world. But with all this incredible power to connect comes a dark side: vulnerabilities. So for our last section, let's bring it all back home to you. Because out there on those digital highways, there are definitely some dangers. The most common one is malware, which is just short for malicious software. And this isn't just an annoyance, it's a full-on arms race between the bad guys trying to break into systems and the good guys trying to secure them. At the end of the day, malware's goal is always to use your computer for someone else's benefit, not yours. So knowing how to protect yourself is absolutely essential, because a lot of the time, we, the humans, are the weakest link. It all boils down to some simple but super powerful digital habits. Use strong, unique passwords for everything. Get a password manager. Be careful about what private info you share online. And please be super skeptical of random links or downloads. Oh, and pay attention to your machine. If it suddenly starts running really slow, that could be a warning sign. So, from a simple physical touch to a global network of information, we've traced the entire incredible system. It connects billions of us, and it's without a doubt one of the most powerful tools humanity has ever invented. So the only real question left is, now that you see how it all works, what are you going to build with it? What will you share or create?